recording. This guy is called a 1 prop Z interval, 1 prop Z int in your TI. If you're using your TI, some of you might be using cell phones, whatever, that's fine too, or Excel. Excel doesn't have one of these, FYI, just so you know. So if you want to use some other technology, you have to find one online. And estimating mu is just called T interval. And I want to come back and do one more of these, because it's been since Wednesday. And I think these are so straightforward, whereas these are not as straightforward. I think the additional complexity in the measurements itself makes for a little bit more of an interesting experience. So I brought a little in-class quiz for us to do. It's going to require you guys to pair off and collect some data. So anyway, that's the idea. And the big idea is symbolically. I'm going to see if you guys buy this. See if you buy these two statements. First of all, see if you buy them. Secondly, somebody explain one of them to me. So you can internally go like, okay, it's symbols. I see less than and greater than signs. I always hated those in algebra class, but rules making me use them again. SOB.
They're essentially the same thing.
They're essentially the same thing, Kate. Thank you. They are essentially the same thing. It's just one is for proportions and one is for averages. Love it. Good. Was I being careless? I've noticed I've got some p hats and I've got some p's. I've got some x bars and I've got some u's. Am I being careless up there?
No.
I'm not being careless. Why am I being careless? Okay, but I'm not being careless? You're giving me, thank you. Full faith and confidence in the rule. What do you think, Kate? What do you think?
Your mu and your p are for your whole population.
Okay.
And your p hat and your x bar is for your sample.
Oh, I love that. How about that MOE, that margin of error? What the hell is that? Is that part of the population or the?
Right.
Oh, good. Spread in the population or the sample? Yeah, absolutely. You're never going to know the spread in your population. As a matter of fact, I'm pretty ballsy putting p or mu up there at all, aren't I? How the hell yeah I am. Why did I even put up there? Lauren, go.
Like 95% which is our population, is within our sample, plus or minus, are right there.
I'm ballsy in putting these in here because there's no guarantee it's actually there. There's no guarantee that little p is between this statistic and this statistic. All we can say is, with a set level of confidence, it'll be between there. So with 95% confidence, that's what we tend to default to, is 95% confidence. What does that mean again? 95% confidence? What does that mean again? State that to me. And don't say there's 95% chance it's in there, because that's not technically correct. It either is or it isn't. Just say it to me a different way. Go ahead, Kate, go ahead.
On average,
Like that.
95% of the time, the average will be.
I like that. I like that. If we do these trials over and over and over again, in 95% of instances, the parameter you're looking for is going to be between these two statistics that you've created. That means you're going to miss sometimes. You're going to miss 5% of the time. And that's okay. That's called an error. We're going to start looking at that today, actually. But you can get more confident by making it 99 or 99.9 or 99.999. We don't like doing that in general. We'll see why probably on Wednesday. But that's what it means. It means that if you replicate these studies, which should always happen, 95% of the time, if you've drawn good studies, you're going to trap what you're looking for between these two. So you can never just come out after a study and say, that's the answer. P hat equals P, without slapping these margins of error on here. Same thing goes with X bar and the margin of error. Same thing goes with that guy. Yeah. Good. So there is definitely some unknown, but that's why the course is called probability. It's not called certainty. Mostly because that's not a word. But the idea is there's always going to be an unknown. There's always a chance of being wrong. There's always a chance of being wrong, as long as you analyze that chance. Cool? All right, so let's analyze a great question that I've been reading articles about recently too.